video will show the relationship of the phi function and its exponential function and its Taylor-Maclaurin series sum expansion using the factorial coefficient and double factorial coefficient. We begin with the phi function, which is array formula of the phi function. So values x from -2 to +2. And the exponential function, array formula, exponent of the x values. And the Taylor-Maclaurin series of expansion, which is the summation of a times x to the power 2n, where a can be the factorial coefficient or a2 the double factorial coefficient. And the value of n is from 0 to infinity. In this case, 16 is good enough. Continue with the factorial coefficient, so array formula. That is array formula. -1 raised to the power n. Divided by, there are two parts, factorial of n. That's the first part. Second part of the denominator is 2 to the power n. That's 2 to the power n. Then enter. We continue with the double factorial, which is array formula. -1 raised to the power n times double factorial 2 times n minus 1 divided by, the denominator is factorial n, factorial 2n, factorial 2 times n. And enter. The values here are exactly the same, except for the first item. We'll correct this. So, if n equals 0, then it should be 1. So we'll correct this. If n equals 0, then 1. Otherwise, calculate. Now their values are exactly the same. Continue with the expansion, which is array formula. SERIESSUM of the x values raised to the power 2n. 2n starts from 0. Then followed by 2, 4, 6, 8. That's incremented by 2. And the coefficient, you can choose the factorial or the double factorial. We start with the factorial coefficient. And we'll chart this. So insert chart, and we'll use scatter chart. Use row 1 as header and show the trend line. That's polynomial to the 8th degree. And use the equation as label. And the legend, position at the bottom. In the case of the yellow, because you don't have a yellow in the dataset, we'll change that to green to match our dataset. So here we have the trend line and the polynomials. So the polynomials and the trend line. We'll also clean this. So we go to the vertical axis. And the number format on the vertical axis will be none. That's better. And we calculate this polynomial regression coefficient using LINEST. To do that, we complete the LINEST matrix starting with the power. Transpose 0 to 8. and the elements of the matrix. So this is array formula of the x values raised to the power 0 to 8. Then enter. Now we calculate using Linus to calculate the polynomial regression coefficient of the expansion. Data y and data x. Then the phi function, so Linest, data y, and data x. Enter. And the exponential function, data y, and data x. Now we'll modify. Let's modify the phi function and the exponential function to match to the expansion. So we'll modify first the red one, the phi function. That is square root of 2 pi. So multiply to phi. So that is square root of 2 times pi multiplied to phi. Then enter. Now their values are exactly the same. And their polynomial regressions are the same. So their polynomials are the same. Next, we modify the exponential function. Here we have minus 0.5 times x squared. So minus zero point 0.5 times. And then it's squared. So raised to the power 2. Now they are all in the same trend line. Their data sets are all the same. Their polynomial regression coefficients are the same. So therefore their polynomials are the same. Let's check this. Coefficient of x to the 0, 1. Coefficient of x, 0. Coefficient of x squared, minus 0.5. Coefficient of x cubed, 0. Coefficient of x to the 4th, 0.123. Coefficient of x to the 5th, 0. Coefficient of x to the 6th, minus 0.0182. Coefficient of x to the 7th, 0. Coefficient of x to the 8th, 1.28 times 10 to the minus 3. Suppose I will use, because I'm currently using the factorial coefficient, I want to use the double factorial coefficient, which is this. Let's enter. The data sets are still the same. The polynomial regression coefficients are still the same. The lines, the trend lines are all collinear, and their polynomials are all the same. This completes the use of double factorial and factorial, the phi function and the exponential function, the relationship with its Taylor-Maclaurin series sum expansion.